So till now, I have explained you that you have a grammar which is made up of non-terminals, terminals, a starting symbol, and some production rules. Okay, so these are the production rules, right? And I have also shown you that how you can drive more productions. So using this production, I have derived more productions. I have replaced A with an empty string, a null string. This is known as derivation. Using other productions, you can just drive the production. Okay, so now I will just do this derivations from a grammar with you in more detail. Okay, so now the topic is derivations from a grammar. Okay, so your strings may be derived from other strings using the productions in a grammar. Okay, so if a grammar G has a production, so if your grammar has a production of the type alpha goes to beta. Okay, so we can say that, so if a string is there, x alpha y, right, that goes to it, you can write it like this. If there is a string x alpha y, so do you agree you can write it like this, x beta y? Why I am writing it like this? Because your alpha can be replaced with the beta. How I can say that? Because this production is helping me to drive this thing. Okay, so alpha to beta is a production rule that you are available with. Then there is x alpha y given to you, and you can write it like this, x alpha y goes to x beta y. Okay, so this grammar is written as that your x alpha y can reach to a new grammar that is of the type x beta y. Okay, so how you write beta? Because alpha can be replaced with beta. These x alpha y is equals to x beta y. These two things are already same, only you replace your alpha with the beta. Let's do some more examples and it will be even more clear. So this is a grammar we have. Okay, so the grammar 2 is the name of this grammar, the same grammar that we did previously. Grammar number 2, it has two non-terminals. What are the non-terminals it has? The non-terminals are S and A. What are the terminals it has? The terminals are A, comma, B. Okay, and S is the starting symbol. That is your start symbol. Okay, and productions are of the form. Can you see? These are the productions it has. Okay, now I am explaining the derivation to you. Okay, so it is telling me that now we can drive. Some of the strings can be derived like this. Can you see? Very first, it has written this thing, the very first production. So it has written S goes to A, A, B. Can you see here? From where it took it? It took it from this. So this is same thing it is writing. S goes to A, capital A, B. Okay, and how it is writing it? Using the production, this production, S goes to A, B, it has written this string, the same string it has written. Now after that, it has started replacing this. Can you see? This A, this A, you can replace it with something. Yes, I can replace this small a and capital A with, can you see? This small a and capital A can be replaced with the double A, AB. So in place of small a, capital A, can I write this thing? So I have replaced it with A, B. This thing I have replaced with this thing. Okay, and this B was there, so I am writing it like this. So this new derivation it has derived. The same derivation I have written A, B, B. How it has derived? It has just replaced this thing with its production. A will be replaced by double A, B. So I have just written it and then B. So same thing is written, that this thing can be replaced with this. Which production it has used? It has used this production. After that, again it is replacing something. Out of this, again this A is replaced with what? With A, B. A, and AA is replaced with A, B, and then 1. This B you have to write like this. Okay, so this A, B, and B. Okay, so out of this one AA, so this A is same, and this AA is replaced with double A, B, and then there is this B. This I think this is one extra. This thing is one extra. Then what it did, out of this A, the only thing that we are left with, it has just replaced it with 5. A, just replace it, and then we are left with B and B. Let me explain it again to you on a whiteboard. Just give me one and recording. Okay, so let me explain. So these are the productions we are available with, and now we are about to drive. Okay, so we always prefer to start driving from the starting symbol. Okay, so the very first production, right, you can write it like this: S goes to A, and B. I have written the same thing. This same thing I have written here. Okay, so now can you see here, you have this AA in it. You have this AA. Can I replace this AA with this thing? Yes, I can replace this A and capital A. I can replace A and capital A with double A and AB. So in place of it, I'm writing A and AB. So this A is replaced by double A, AB, and this B is again here. Okay. Now again, this AA can be replaced by double A, AB. So this A I have to write as it is, and in place of this AA, okay, it is right. In place of this AA, I am replacing it with double A, AB. Double A, AB. So I again have replaced this thing with double A, AB. Now I have still two B's with me, so I am writing it as it is. Okay. Now we are left with only one A here. So can I replace it with 5? A, and this A can be replaced with the 5, means null string. It means it will be removed. And we are left with triple A, triple B. So this is perfect and actually correct. Okay. So I have explained it, and it has given the examples also, that how it has reached from here to here by using which production, from here to here by using which production, and so on. Okay, so you can try it on your own. Okay, now we have regular expressions also in case of a grammar. Okay, so what is a regular expression? I am going to define it, that if I just talk about this empty string, it is a regular expression. It is also an expression. And if you create a language using this expression only, using only an empty string, so you can write it that language for only empty string will contain only empty string. Okay, language for empty string will only be a set that has only empty string in it. Okay, sometimes in a language you don't have anything, not even an empty string. So that language is known as this. I don't remember if you have done this symbol. We call it Xi, right? So Xi is also a regular expression denoting an empty language. It means the language that belongs to Xi has nothing in it, not even an empty string. I'm just explaining different scenarios. So if you have X as a regular expression, okay, so the language will contain only X in it. Okay, now if X is a regular expression denoting the language LX, generally I'm giving you one example, that X is a expression and its language is L, language of X, and Y is a regular expression and it has the language denoting language of Y, right? Then you can do all these operations. You can add the expressions. So if you add the expressions, it means you will get a new language. New language means language that belongs to X union language that belongs to Y. It means language that uses both X and Y has language that belongs to X union language that belongs to Y. This is some mathematical concepts that I'm doing. If you do the multiplication of it, X multiplied by Y, it means expression X is multiplied with expression Y. So the languages will also get multiplied. So the language of X multiplied by Y is language X multiplied by with language Y. Okay. If R star is a regular expression, this is a random example. R star, I will explain later what are these stars and all this. Okay. So the language of R star will be language of R star. Only it has only R stars with it. Okay. So if any of these rules we apply, how many rules we have? 1, 2, 3, 4, 5. And if any language satisfy all these rules, it means those are regular expressions. Let me give you an example here. Can you see? If I give you this example, let me give you an example. This is an easy example. Can you see this? This one. So this is an expression. Expression has value 1, 1 star. Okay. It means it has even number of ones in it. Expression has even number of ones. What do you mean by even number of ones? It means it has 2 ones in it. And also there is a star above it. So what do you mean by star? Star means it will repeat itself. So the language will be of the type. Can you see? The language will be of the type. The language can have a null string. Can you see? It has a null string. Then it has 1, 1. So this star you can represent it with power. Okay. So if power is nothing, so same thing will come. So if you repeat it, it is 1, 1. Next time it will be repeating it 4 times because only even numbers are coming. 2 times 1, 4 times 1, then 6 times 1. Then next is 8 times 1 and so on. So if an expression given to you is this, the language that you can generate is this. Okay, let me give you this example, this one. Okay, so here what is written? 0 star 1 0 star. So some things are repeating. This 0 is repeating. Maybe there is no 0 at all. Okay, if there is no 0 at all, the very first will be only 1. Right? If there is only this 0 and this 0 is not repeating, so 0 and 1. This 0 is not there, this 0 is repeating once, 1 0. All these are there, 0 1 0. Okay, this is repeating twice, this is single, double 0 1 0. This is single, other one is repeating twice, and so on. Okay, so this is how you can create the, you have the expressions with you and you can create the languages. Okay, so any set that represents the value of the regular expression is called a regular set. Let me give you an example. Okay, so suppose there is just listen to this and it will be very clear to you. We have a regular expression here. This is a one regular expression. Okay, and what is the value of it? Regular expression 1 is that a is there and then double a can be repeated any number of times. So if I use this regular expression and creates its language, so let the language is denoted by 1, L1. Okay, so suppose this is power. So suppose this power is like 0, it never comes. So it means it will be only a for the first time. Next time, if its power is 1, it means it will come once. So it will be a and a. Okay. Next, if its power is twice, right? It is repeating 2 times, right? So it will be a and then this thing repeating 2 times, a. Next time, if this thing is repeating, 4 times, it means 3 times. Here we have repeated it only once. Here we have repeated it twice. Now we will repeat it 3 times, a A 2 times and 3 times. So this is an expression, and this kind of language you can generate out of it. Yeah, I hope that you will understand this. Okay, so what was the regular expression? Regular expression one was A star. This was the regular expression. Now here star means power. Okay. Power means that you can write it with the value 0 power, 1 power, 2 power, 3 power, and so on. Okay. So the very first language set can be where you are not repeating it. It means very first set is made up of only A and then A to the power 0. It means nothing will come here. Something power 0 means 1. So only A will come. Next time I am writing A with the power 1. So what will be the next string generated? It will be A. The next one will be A with the power 2. 2 power means it will be repeated twice. Okay. So if it will be repeated twice, so what will happen? This A will be written once and this will be written twice. 1 time A, 2 time A. Next is A power 3. It means this A will come once and this A will come thrice, and so on. So there is one more regular expression, double A star. Okay. So if we just represent it here, okay, so just clear it. The next regular expression is RE2 equals to double A star. So what will be the value in it? This star will be 0. It means nothing. You can put 5. Then this star will be 1. It means AA only once. Then this will be 2. It means AA coming twice. Then 3. It means AA coming 3 times, and so on. This is your second one. Can you see the language 2 means if it is not coming at all, the very first one will be 5, then AA once, then AA twice, then AA thrice. Okay. So if you look at this, the language 1, can you see the strings of odd length, all the odd lengths, and there is no null. There is no this 5, this empty string, because at least A is coming at the beginning. First A is coming, next A is coming thrice, then A is coming 5 times. So strings are generated of only odd lengths. Here, the second language we generated, strings are only of the even lengths, double A, 4 times A, 6 times A, and there is also one null. Okay. And if you do the union of two sets, L1 union L2, that I explained previously. So if you do the union, it means all the values will be written. If there is any repetition, that will be replaced. So first empty string, then A, then double A, then triple A, then 4A, then 5A, 6. It means strings of all the possible lengths. It means 1, 2, 3, 4, 5, 6. All the lengths are generated, and there is also one null because of it. Okay. So if you just want to write it, this is the language L1 union L2. It has this empty string A star. So can you write the expression for this? The regular expression for this language? Yes, it is A star. Can you see it is A star? A star. If there is no A star, it is 0. There is empty string. Then A star 1, 1, A star 2, 2, A star 3, 3, A star 4, 4 times, 5 times, and 6 times. And it is also a regular expression. It means if you have two regular expressions and you do the union of it, the language generated, and you got again the regular expression out of it, that is again a regular expression in itself. So two regular expressions, when you calculate the union, the third thing that you get is also a regular expression. So this thing has proved it. So with this, I am about to end this class, and I hope that you have got a clear understanding and do the revision on your own, and the concepts will be even more clear. Thank you.